Okay, so now we're going to talk about combinations. So this is lesson 5. Combinations are different than permutations. Permutations, order mattered. Combinations, order does not matter. So the one we use is NCR. So it's N objects and you choose so many of them. Okay, so let's look at this one. We've got flavors of ice cream. So there's 10 flavors in total. So if order mattered, right, you'd have to deal with this. But order does not matter. It doesn't matter if we order, let's say, vanilla, chocolate, and strawberry, or whatever the order happens to be. Okay, so this person, Danielle's getting a sundae. 3 different combinations. So we go 10 times 9 times 8. But what we do is we have to divide it by 3 factorial. And 3 factorial is because we're talking about 3 scoops of ice cream. The order doesn't matter. So we divide it by 3 factorial, and that really will reduce the weight. So 120 weights. So to put that in as 10 choose 3, you can plug that into your calculator much faster. You get your 120 weights. Okay, so flip to the next page and let's look at example 2. So what we got is we're forming a committee. So there's 13 volunteers, so 8 teachers and 5 students. And the principal has to choose a 4-person committee that has at least 1 teacher. So there's a lot of different possibilities here. You could have 1 teacher, 3 students, 2 teachers, 2 students, 3 teachers, 1 student, and 4 teachers, 0 students. So those are the 4 possibilities. So let's look at the first one. So for this one, we do 8 because we get to choose from 8 teachers, so there's 8 choices, and we divide by 1 factorial because that's just the order that they're putting them in, times, these are the students here, 5, 4, 3, and we divide by 3 because it doesn't matter the order that those students are picked. So we plug that into the calculator, we get 80 ways. Now, an easier way to do that would be 8 choose 1, this is for the teacher, and then 5 choose 3, right? Choosing 1, choosing 3, that gives us our 1 teacher and our 3 students. And again, you plug that into the calculator, you'll get your 80. The next restriction is 2 teachers, 2 students. So teachers, we can go 8 times 7, because there's 8 teachers in total, so 8 and then 7. And 2 factorial, because it doesn't matter the order that we're picking them in. And then for students, 2 students, so 5 times 4, again, divided by 2 factorial. And again, you could figure that out with your calculator to get 280. Now, nicer way to do it is 8 choose 2, right? 8 teachers, choose 2 of them. 5 students, choose 2 of them. And multiply this together, and you'll still get the 280. Same for 3 teachers, 1 student. We could do 8 times 7 times 6 divided by 3 factorial. 3 factorial because there's 3 ways of picking them. 1 student, which is 5, and then 1 factorial, and we get 280 ways. Or use the formula, 8 choose 3, right? 8 teachers, choose 3 of them. 5 students, choose 1, and you'll still get the 280. And the last option is 4 teachers, no students. So 4 teachers, 8 times 7 times 6 times 5, 4 factorial because it doesn't matter the order. Don't care about the students at all. So then we can look at it as 8 choose 4, and there's no choosing of the students here, so we get 70. Now, to find the total, right, it could be this committee or this committee or this committee or this committee. That's why we add them all up, and we end up with 710 ways. Okay, so that is the last lesson of the counting methods section. Okay, and you can do the questions that are at the bottom of them, and the next notes that'll come through are probability notes.